So I'm going to continue on with this section 2 where we were talking about multiplying and dividing rational expressions. And really in the first part, so part 1 of this section, we were talking mainly about looking at one singular rational expression and being able to reduce them by factoring, crossing off like terms, crossing off like factors, those kind of things. I'm going to add in an extra step now, and we're actually going to be multiplying and dividing these rational expressions. Now, we do this the same way that we would divide or multiply regular fractions. So I have a couple examples. Remember, when you're multiplying and dividing, you do not need common denominators, which makes multiplying and dividing a lot easier than adding or subtracting. So for this first one, I have 2/3 times 9/4. Now, you could go ahead and multiply right across the top, right across the bottom, or what you could do is reduce before you multiply. And you can do cross-reducing on these types of problems as well. So 3 and 9, I can take a 3 out of both of those. So this 3 becomes a 1, and this 9 now becomes a 3. I can do something similar with the 2 and the 4. 2 becomes a 1, 4 becomes a 2. Now if I multiply across the top, I have 1 times 1, which would be 1. And on the bottom, I have 3 times 2, which would be 6. And so I would get 1/6 for my answer. Now I would have gotten the same thing had I just multiplied straight across. I would have gotten 6/36. And then I would divide both of these by a 6 and reduce that 6 out. And I'm still going to be left with 1/6. So for this one, 5/6 divided by 10/24. Remember, the key thing here is that they've thrown in this division symbol. You're not going to do anything to that 5/6, but we do have to change this slightly. We never actually divide fractions. We change it to a multiplication problem, and then we find the reciprocal of the second fraction. That's when you flip the fraction upside down. So it's going to become 24/10. Now what I'm going to do is cross-reduce like I did on that last problem. 6 can go into 24 4 times. 5 can go into 10 2 times. Then I can also reduce this 4 and this 2, because 2 can go into 4 twice. And so really what I'm left with is on top is 1 times 2, which is 2. And on the bottom I have 1 times 1, which is 1. So I don't really need to put 2/1. I can just leave it as a 2. So we're going to do similar things here with our rational expressions. We're going to factor all numerators and denominators completely. So similar to what we were doing in the first part of this section. Write out those factors and then cross out anything that they have in common. So figure out if there's anything that they share, reduce them, get rid of them. Then whatever's left, you multiply and you go ahead and write your final answer. And just make sure that you are watching for division signs. You want to make sure that you're changing division problems into multiplication problems. So for this first one, for the first fraction over here, I need two numbers that multiply to 12 and add to 7. And that's going to be 4 and 3. Both are going to be positive. So x plus 4, x plus 3. On the bottom, we're going to have x minus 5 still. Now for the second fraction, I'm going to factor out the 2 because that's the only thing that they have in common on the top. And that's going to leave me with x minus 5. And then I have x plus 3 still on the bottom. So remember, when I'm reducing, I can reduce something from the top of something on the bottom. And I can now do this cross-reducing as well. You cannot reduce things if they're on the same level of the fraction. So if they're both in the numerator or they're both in the denominator, you cannot reduce that way. You can only reduce something from the top, something from the bottom. So my x plus 3's, those can cancel. My x minus 5's can cancel as well. So what's left on the top is your 2 from the second fraction. And that x plus 4. We normally put the number out front, which is why I started with the 2. And on the bottom, there isn't anything left. So it's like thinking about that over 1, which you don't really need to have. You can just leave it as 2 times x plus 4. Go ahead and pause the video and try this one. And then when you're ready, go ahead and resume, and I will walk through it with you guys. So what I'm going to do is factor the left side first. Now on top, you would have maybe had to do longer factoring, kind of like that A times C and then adding to your B method. If you don't remember doing that, I mean, you could always just kind of guess and check your way as you're trying to factor that out. But you should have been left with 2x plus 7 and x minus 1, and then that's over x plus 4, times, on the bottom I'm going to factor out an x, and on the bottom it factors to x minus 1, x minus 1. Now to simplify, I can get rid of an x plus 4, and I can get rid of one of my x minus 1s, and so I'm left with, on the top, x times the 2x plus 7, and on the bottom, x minus 1. Now, these next couple are switching gears a little bit by making us do division. So make sure that you rewrite the second fraction as the reciprocal, and then think about like your factoring. So on this first one, I'm going to go ahead and on the top pull out a 12. And so that leaves me with x plus 4. On the bottom, I can take out a 3. And that will leave me with a 2x minus 5. Now changing this to a multiplication problem, and I'm switching this fraction, so I'm flipping it upside down. So the 4x squared minus 25 is on top now. Now that's another difference of perfect squares problem, because the 4 and the 25 are both perfect squares, and there's a minus sign in the middle, which means I can square root both of them. And so we had one like this in the part 1 of the section here. You're going to have a 2x minus 5 and a 2x plus 5. You have to make sure that you're recalling some of those factoring rules that we've had in the past. Now that x squared plus 9x plus 20 is now on the bottom, and so I'm factoring that by finding two numbers that multiply to 20, add to 9, which would be 5 and 4, both positive. So I can cross off a x plus 4, a 2x minus 5, and the other thing I can do here is 3 can go into 12 4 times. And so I'm going to be left with, on the top, 4 times 2x plus 5, and on the bottom, an x plus 5. The really important thing that you remember to do here is change that division sign to a multiplication sign and flip the fraction upside down. Don't forget to do that part if you're not specifically going to write it out as a new multiplication problem and you're going to kind of combine those steps together. I see that as a common mistake where the student forgets to flip the fraction upside down and they write the factors on the wrong part of the fraction. Go ahead and pause the video and try this one, and then go ahead and resume when you're ready to see me work it out. Again, this one is a division problem, so we'll have to make sure that we flip that second fraction. On this first one, what I'm going to do, think about if I wanted to rewrite this, it would say negative 4n plus 16. So I'm going to go ahead and switch it like that. And the reason why I'm going to do that, let's focus on the bottom here for a second. I need two numbers that multiply to a negative 24 and add to a 2, which is going to be m plus 6, m minus 4. So what I want to do actually on the top is take out a negative 4 so that it becomes m minus 4, and I'm going to be able to cancel those off. We saw an example like that also in section or part 1 of this section 2, where I did a similar thing, and I kind of worked it out a little bit more in that last example. Now times, I'm going to flip this fraction upside down so that m minus 4 is on the bottom, and I'm going to take a 3 out from the 3m plus 18, and that's going to leave me with m plus 6. So now I can cancel an m minus 4 and an m plus 6. What I'm left with then on top is negative 4 times 3, which would be negative 12. And on the bottom, I have m minus 4.